Let's now look at what happens when two objects A and B, interact with each other. So if these two objects interact, we will get forces acting. The first force here is FAB, which is the force of object A onto B. And then, of course, we have the opposite force, according to Newton's third law, which says FBA. And we know these two forces are related. They're just equal and opposite forces. So let's say when these two things interact, and we have these forces that are applied to each other, if we multiply by delta t, we will get the impulse on both sides here. So I have the impulse of A on B is equal to minus the impulse of B on A. Of course, impulse is change in momentum. So I get the change of momentum of object A is equal to minus the change of momentum of object B. And of course, we know that momentum is m times v. But let's go ahead and multiply this out. So I have P final A minus P initial A equals negative P final B minus P initial B. And then, of course, you can multiply that through, so it switches the sign. So I get P initial B minus P final B. Then I get all the initials on the left, or all the finals on the left and initials on the right. So I have P final A plus P final B equals P initial A plus P initial B. Here we have finals equals initials. So this leads to a conservation law. In this case, the conservation of momentum. Right? The momentums, the sum of the momentums before equals the sum of the momentums after. So as objects interact, their individual momentums will change, but we will get the total momentum conserved in every interaction.